Hey there, my name is Frank. I am continuing the revision of my prototype of my game that I'm calling Castle Wars. Working title. Last time we got fishnet working, so we got a bunch of clients to be able to connect over a network. We sorted out all of the menu management, the device handling, the input routing, that sort of stuff. This time we have quite a bit more. So we're going to start with loading maps and implementing a loading screen. Second, in order to implement custom games and to just generally save a bunch of time, I want to be able to generate a settings menu from some list of settings. And then we can use that to make the player settings menu, as well as to give the lobby host a way of editing stuff like the map, the mode, the number of teams, the number of players, all of that stuff. Once we're done with that, we're going to implement some Steam support. The lobby was created last time, we got everyone connected and that was working, but we kind of need to generalize it so it can work over different transports and not just on one computer. That way we can use it over the Steam network or the Nintendo network or PSN, whatever. And then we just have to write a new module to keep all that stuff in sync. Okay, so let's jump into this. So I started by making the world's second most basic multiplayer map. I say that because it has walls and some geometry, not just a plane. Could be more basic, whatever. Now we have a map, we need to be able to load it, right? So Fishnet provides a component called the scene manager, which when called from the server will cause all of the clients to load the same scene at the same time. So that handles all of the actual loading in and out of scenes. However, what do we do while those scenes are loading? In order to hide the map loading and the syncing of everything, we're gonna need a loading screen. So I quickly threw together a loading screen. It just has some basic information in the top left. It has the map and the mode, and then on the bottom there is a progress bar with a percentage text and some status. We load the map on our computer, and then we have to make sure that everyone else's computers have already loaded it so that we don't get some weird advantage. The loading screen has some status text to indicate what part of the loading process we're in. It looks like this. So next we're going to switch gears a little bit. I want to get the auto-generating settings menu out of the way since it seems like it's the single hardest part of the sprint. Let's just do it. So in Devlog 2.1, which for anyone who's been following was the Databox settings one, I built something very similar to this. It just wasn't auto-generated. We need some way for not only mouse and keyboard, but also controllers to interact with settings and change the saved value. So I derived our controller node class that we made last time, and I made a controller node value select class, which is like a node, but it takes all of the input from the controller and it funnels that towards this selection interface. And our selection interface just moves, it increments a value up or down, which is left and right on the controller. Which brings up a good question. How are we representing settings? I've made the executive decision of representing a setting as a list of strings with a stored index. Mostly because this is a type that Databox supports, but also just because it's the only way of storing all of the necessary information for each setting. So the list of strings is all of the possible values, and we can cast those to whatever type we need to cast them to. The index is the selected value, so we can change the index, and that changes what the setting is set to. And then the name of the value in the Databox is what we're going to use to tell the player what the setting is. So it could say like field of view. We have all of our possible options for field of view stored as a list, and then our selected index is what it is. That's what we're going with for now. I also created what is so aptly named a value select Databox sync component, which when you put that on the same object as a value select and give it a table entry and value name, it will automatically detect when the value select has changed the value, and it will push that updated value back into the Databox. Now we have a way of representing settings and we have a way of editing settings. We need a way of storing them and supplying these stored objects. I haven't fully explained what a Databox is in this video. I made a whole devlog on them, but in short, a Databox is a triple nested dictionary which stores values of varying types collected into an entry, and we can collect those entries into a table. And then the Databox is a collection of tables. Yeah, so it's sort of just a complex dictionary which allows you to look up a value given a string name for its table entry and value. What's weird is there's a value associated with a value. I don't like their naming scheme, but it's their naming scheme, not mine. I built a settings manager which contains a reference to two data boxes. One I'm calling the default for the player settings, and one is player one's settings. They are, at least at the start, two identical copies. It's just that player one settings need to be stored to the disk, so we need some way of actually saving that as its own thing. And we have the default, which is what we're going to use to, at runtime, add settings objects for player 2, 3, and 4. Since they don't need to be saved to the disk, they can just be created at runtime by cloning the default. So when the game manager adds a player, we'll detect that it needs a settings object, clone it from the default, and then save a reference to that copy that we can edit. Okay, so now we have data boxes which store settings, and we have a way of editing these settings so we can generate the menu. We can make the menu generator. First thing that needs to happen is we need to generate a left-hand side. And I made the design decision that we're gonna have a left-hand side of shortcuts and a right-hand side of values. So the left-hand side contains a back button as well as shortcuts for each entry in the data box. And I'm assuming that there's only one table. Technically, you could abstract this so that you can use multiple tables, but I'm assuming that there's just one table named settings. So we generate our list of shortcuts. The right-hand side is our list of entries, and each entry contains all of the values from the data box, and each of those values is our settings. So we have our entry with a title and then all of its stuff. The controller navigation gets auto-generated, and so does all of the scrolling. This is like really high level. I'm not gonna like post code or do anything to like actually show how this gets generated, because you can kind of come up with it on your own. Actually, if you do want to see some of the code and some of me actually figuring out how all of this is going to work, I posted a play-by-play video a couple of weeks ago. It's like stream highlights, except it wasn't a stream. If you want to hear me rant or get really confused or anything, just go watch that. There's timestamps for each of the big topics, and auto-generating settings is one of those topics. It's like half of the video. If you're more interested in how that works, definitely go check that video out. If not, continue watching this one. With the auto-generating settings menu complete, we can now just, boom, add a settings menu. And then if we wanted to, we can copy paste that into that modal menu we created last time, and boom, now we have a settings menu. If we just allow it to take player 2, 3, or 4's data box for their settings, then they can edit their own settings, and the values are persistent because that data box exists in the runtime. Similarly, we can use this auto-generating settings object, and we can make a different data box. We can make a game settings menu, which is only available to the host in the lobby, but we can generate one of these menus for stuff like selecting the map, selecting the mode, selecting the number of teams, and then the number of players, which will just increase how many people can join the lobby. So I added a game settings manager, which is a networked component underneath the game director, and it will store a basic data box for game settings, which then gets given to the host when the host wants to edit the game settings, and then they'll edit it and it'll get pushed back. So the only issue is that these data boxes don't get synced over the network. Why? So fishnet supports sync lists and sync dictionaries, right? And if a data box is a dictionary, it's a complex one, but still, why doesn't it work? Well, a data box is actually a lot more than a dictionary. It's a class. So it contains a dictionary, but it also contains a bunch of logic for how to write it to the disk, how to read it from the disk, how to encode it different ways, how to compress it different ways. All of that stuff is great, but we don't need to send it over the network. All we really need to do is take out that dictionary structure and replicate that. And we have sync dictionaries, so we can do that. I added a triple nested dictionary to the game settings manager. Basically, it allows us to get and set values with our table entry and value names. I wrote a couple of functions, one being a data box to dictionary conversion and one being a dictionary to data box conversion. So now we have this loop. When the host decides that they want to edit the game settings, the game settings manager will take its sync dictionary, convert it into a data box, and give that to the host. The host will then make all the settings to the data box, and then when they hit back, then that data box will given back to the game settings manager, which will convert it to a dictionary and sync that dictionary over the network. So there we go. There's so many for loops. Transport switching. Realistically, this all could have waited until the prototype was done, but I want to try using the Steam relay to figure out what kind of latency there is, and to me, this prototype is never going to be a full prototype unless I can play it with my friends. I need some way of getting the game from my computer into some network as a point of discovery that other people can find, and then we can all connect and play the game together. This poses a significant issue with our network interface, because the network interface assumes that we're just using a local connection, and then either starts or connects to the local connection. But what happens if we want to, say, have a local connection, then disconnect from it, connect to a Steam game? Or what if we want to like pull usernames or avatars? We can't really assume what transport we're using. I couldn't figure out how to replace transports at runtime. I couldn't figure out how to deactivate Tugboat, which is the local one, and then activate fishysteamworks, which is the Steam one. But Fishnet has a transport called Multipass, which allows me to run both at the same time. So they both get initialized on startup, and then I created what I'm calling a transport sync object, which has a reference to one specific transport and controls that specific transport. So even though they're both running at the same time, we are only passing functions to one or to the other. The network interface has been modified to take in these functions that we were already doing and then just passing them to a transport sink by keeping track of the current active transport is and associating each one of those active transports with the transport sink. It's a lot of words, but basically message goes into the network interface. It will just look at what transport we're using and either go local, Steam, or anything else. So now our network interface is actually an interface. We have this transport sync object. The local one I derived, and I derived it from the default, and it does exactly the same as everything that we already had on the network interface. It's just in its own thing. I also added a function that returns an avatar and a username, which just return defaults, so a default image and a default string. So the Steam transport hosts and leaves games just like the local transport does. Joining a game needs a Steam ID because that's what the transport needs, so we're going to handle that later. The Steam transport sync is also going to create and maintain a lobby data object, which is part of the Steam API. It will sort of parody the state of the lobby as well as some metadata over the network so that the game can be accurately discovered and joined. That's all through the Steam API, and we only have to keep that up to date if we're using the Steam transport. Just like on the local transport sync, I also implemented a way of taking a network ID, pushing that to the Steam database, and getting back an avatar and a username so that we can say on the main menu, show our own player card, or in a lobby, show a player card. So I said that we needed a Steam ID in order to join a lobby with fishysteamworks, which we do. And I implemented a lobby browser in the past because in Devlog 3, I sort of got used to the Steam API and followed a couple of tutorials on my own to build my own lobby system with team switching and actually pretty much all of the same features that I'm going to implement this time, but just using the Steam API. So even though we had fishysteamworks, we never actually started a game with it. So I copied all of the code and I copied all of the lobby browser UI stuff over. So we can now click join, we try and join the lobby over the Steam API, we'll get an API callback, which will give us a Steam ID, which we can then use to join the fishnet lobby. So we now have lobbies over the Steam network. So let's show who's in the lobby. I really quickly smashed together some team panels, which get populated with either everyone in team 1, everyone in team 2, or there's a free-for-all panel which just has every single player. And each player card automatically pulls the username, the local ID, so like if we have two controllers on the same computer, and the avatars for each user, so that way we can identify who's who. Players can join a team by clicking a join team button. Again, if there's multiple controller players, they will join actually with the D-pad. They'll either go left or right to join a specific team. Because we're not using solely API calls and we're actually just using the fishnet, we can do all of these operations and stuff, and it's actually faster than it was in Devlog 3. And I also separated a lot of the refreshing events so that it doesn't change everything every time there's any micro update. Lastly, I built another one of those modal menus which allows you to quote unquote pull up a specific player. This is where I will later add the ability to promote someone to the leader, kick them, or view their online profile. Promotion is going to be a hell of a fun time to program because that requires telling someone else to start a server and copy all the data and then telling everyone on the current game to connect to that one. I don't want to do that, but it's going to be fun. So what's next? You may be asking, when are we going to actually make the game? And I'd argue that we already are, but that's fair. The next devlog is effectively going to be what was the first devlog, but networked. So we're going to have character movement, mouse looking, controller looking, jumping, double jumping, dashing, crouching, sliding, swimming, falling, climbing, a HUD, a pause menu, a health system, an interaction system, maybe some network sounds, maybe some network animations, stuff like kill planes and moving platforms and ladders and all of that stuff. That's the next video. And actually, let's see how blurry is the screen behind me. It better be blurry because that's important information. See that? So now if you go to the training ground, oh, look at this. Ooh. Alright, well, that's your little sneak preview. Get subscribed because that's probably the coolest shit I've ever made. And yeah, like the video, comment, tell me everything that you want me to do, and I'm not gonna do it probably because I don't have time. It would be cool, and it'd boost my engagement, and I want these videos to pop the fuck off, so that'd be really cool. All right, thank you.